Parker Solar Probe, which was launched by NASA in 2018 and has been operating for 3 years, has entered the Sun's upper atmosphere. One small step for the probe, but a giant leap for solar science is being taken. NASA announced today that new findings from this monumental research project has been published. Using the Parker Solar Probe, scientists were able to sample particles and magnetic fields from the Sun's corona, resulting in numerous new discoveries. Here are some behind-the-scenes photos from this momentous occasion in history. There is a constant stream of charged particles emanating from the Sun that affects all of the planets in the solar system. The solar wind is responsible for this. On July 11, 2018, at Astrotech Space Operations in Titusville, Florida, NASA's Parker Solar Probe was hoisted into the third-stage rocket motor for the first time. Additionally, the Parker Solar Probe will make use of a third-stage rocket to achieve the speed necessary to reach the Sun, which will require 55 times the energy required to reach Mars. The Delta IV Heavy will be used as a primary launch vehicle for the mission. Since its launch in 2018, the Parker Solar Probe has been orbiting the Sun, getting closer and closer to the Sun with each loop. According to Alexandra Witz's Nature article, the probe finally crossed into the outer atmosphere on April 28 and remained there for approximately 5 hours afterward. Astronautic missions to the stars, discoveries in the unknown, and questions about our own existence are all possibilities. If any of these interest you, please subscribe to our YouTube channel and continue your exploration of the vastness of the universe. Solar winds are streams of charged particles that radiate from the Sun's corona and carry a magnetic field. The probe crossed the Alpheven critical surface, which is the boundary between the end of the Sun's atmosphere and the beginning of solar winds, which are charged particle streams that radiate from the Sun's corona. According to a press release from the Harvard-Smithsonian Center for Astrophysics, CFA, researchers built and are monitoring a key instrument on the spacecraft called the Solar Probe Cup, which collects particles from the Sun's atmosphere. Using data from the Solar Probe Cup, it has determined that the Parker Solar Probe entered the corona 3 times on April 28, with one of those dips lasting approximately 5 hours in the outer atmosphere. The device is constructed of heat-tolerant materials such as tungsten, niobium, molybdenum, and sapphire in order to withstand the Sun's extreme temperatures. The ultimate goal of this entire mission is to gain an understanding of how the Sun works. In order to accomplish this, we will need to fly into the solar atmosphere. According to Michael Stevens, an astrophysicist with the Center for Astrophysics, in a statement he said, "The only way to accomplish this is for the spacecraft to pass through the Alpheven point, which is the outer boundary defined by scientists. As a result, one of the most important aspects of this mission is the ability to determine whether or not we have crossed the critical point. In previous calculations, scientists estimated that the boundary was located between 4.3 and 8.6 million miles away from the Sun's surface. By crossing the threshold at 8.1 million miles away, the Parker Solar Probe confirms that their estimates were within reasonable bounds. It's also confirmed that the boundary was not a smooth sphere, but rather had spikes and valleys, as they had hypothesized previously." According to the press release, understanding how these wrinkles line up with solar activity could aid scientists in their understanding of the dynamics between the Sun, its atmosphere, and solar wind. In addition, the spacecraft provided new insights into switchbacks, which are zigzag-shaped structures in the solar wind that were previously unknown. The data collected by the probe, despite the fact that scientists were already aware of them, suggests that they originate in the photosphere, the visible surface of the Sun, and contain higher concentrations of helium. The Parker Solar Probe assisted in the discovery of some of the zigzag structures or switchbacks in the solar wind. Stuart Bale, an astrophysicist at the University of California, Berkeley, and a study co-author, is optimistic that the data collected by the spacecraft will aid in the resolution of the mystery. Despite the fact that the Parker Solar Probe has already provided a glimpse into the Sun's atmosphere, its mission is not yet complete. It will orbit the Sun 24 times during its lifetime, and in 2025, it will be closer to the Sun than it has been ever before, only 4 million miles away, according to Nature. Although it appears to be a long distance, experts believe that if the Sun is in the end zone of a football field, Parker will be at the 4-yard line. Thanks for watching, and we'd love to keep you updated on all our future videos. So hit the subscribe button and the bell icon to be a part of our YouTube family.